So today I will discuss about digital filter structures. The very simple configurations. So in the syllabus you can see the direct from 1, direct from 2, cascade, parallel, many different types of structures for implementing filters, a digital filter. So we know that there are two categories. One is FIR filter, ionized impulse response, and IIR filter. So both of these structures can be implemented using this type of techniques. Is direct from 1, direct from 2. Okay. So you will understand how the connections are made for to implement one particular system function. Okay. Maybe of FIR type or IIR type. So what we mean by digital filter is that basically its transfer functions mainly are two types, recursive and non-recursive. If it is recursive, then IIR filter. Okay, recursive means you just have to take the feedback from the output, okay, with different delays like yn. If the output is yn, then output with one delay it is yn minus 1, another delay yn minus 2. They will be added with some weight, either added or subtracted with some weight, and will be added with input both in the form of present and past sequence. So when we take the past output samples, it becomes recursive. When we take only the past input samples, present and past input samples, then it is non-recursive. Okay. That belongs to FIR. And you know that FIR system, it is a finite impulse response. That means within some specific time duration, within some selected sequence, the signal is exist, Hn exists, and outside that Hn is 0. So the length of the impulse response is finite, and outside and outside that sequence it is 0. Whereas in recursive, for all the time sequence, time instance, the sequence exists, and generally it never becomes 0. Okay. In recursive or IR system, Hn is the impulse response that never becomes 0 for any time instance. Whereas in FIR system, it becomes 0 outside the time duration, certain time duration. So you see that there are 6 categories of realizations. So first we will start with IIR type, because both will see how the inputs and output are delayed and they are connected, and finally how the output is obtained. So we'll deal with both delayed versions of both input and output. So first we consider IR, and in case of FIR, It is only the delayed version of input. So that will be studied later. So first we will study IIR structure. You may take the screenshots because I will upload this slide later. So first we'll start with direct form 1. So you'll see some handwritten notes over there. That is visible, I think, clearly understandable. Now direct form 1, what is general difference equation? Difference equation is yn is equal to minus of k is equal to 1 to n ak yn minus k plus summation k is equal to 0 to m bk x of n minus k. You see the index of k in output case y, it starts from 1, and input case x, input case x of n minus k, k starts from 0. Why it is so? Can anybody tell? Why in output case k starts from 1 and input case k starts from 0? Can anybody tell? Nishchay? You can see in the equation it is written in the form, explained in the form of series. In output case, if it is k is equal to 0, that means it is a present sample. So present sample is taken separately in the left hand side of the equation, and in the right hand side the previous version of output and past and present version of input is written. That's why it is there. So this way we write minus a1 yn minus 1 minus a2 yn minus 2. This way it goes to yn minus n. Similarly, input goes from b0 xn plus b1 xn minus 1 to bn xn minus m. So now let us consider one intermediate stage or intermediate function, okay, that actually represents the sum of input, present and past values of input. Okay. So it is Wn, that is equal to sum of xn plus xn minus 1 up to xn minus m, okay, with different weights. So that is the intermediate function. Okay. So we write this way xn, then first it is multiplied with b0, first term is over, then second term we write xn minus 1 by passing it through a delay element z inverse. Z inverse is the delay element. Okay. So it in time domain we can write this way. Okay. once it goes through one delay element, it becomes x of n minus 1, and weight is v1 is multiplied. And similarly, x is more delayed, it is multiplied by p to b2, then so each time input signal is delayed and it is multiplied with weight, and they are added, and we get the term wn. Okay, now this term wn is the sum of present and input, present and previous samples of input. According to the equations, they will be again added with the with what? With past, with the past values of output. So we have the present value of output is yn. We pass it to different delay states. Then we multiply it with weight, different weight, and these are added. So both input and output are added, and we get the output y of n. Okay. So this is the structure, simple structure. Okay, directly we are implementing the delays, the different versions of delayed versions of input and output. Now let us do one problem that realize the second order digital filter. Okay. And the equation is given that yn is equal to 2r cos omega 0 yn minus 1 minus r square yn minus 2, okay, plus xn minus r cos 0 xn minus 1. So it has two sides, two terms. One is the delayed version of output and another is delayed version of input. And you see that output goes up to the order 2, that is up to the term yn minus 2. That's why it is called second order filter, second order digital filter. Now how we will implement this? So as we have done in the first case, that first you take the write the functions for presenting containing the input terms. So xn and r cos omega 0 xn minus 1. So that is the wn. Okay. All of you should do yourself. This one is simple. And output term you write, the output side, then you add these two. So all of you must do this exercise. Okay, these are home tasks for the next for the next class. Before the next class, you have to submit this homework. Okay, like you have submitted in earlier class. Very simple. Okay, so in one folder. Okay, in one folder, make one separate folder and you write the solutions, or you may post, need not file, upload the file, you may post your home task, homework in the post, in the team, in the in the place where you can post, okay, in your message. So this is one structure. Second structure is direct from 2 realization. Okay. So in direct from 2, first here we take the jet transform. Okay, where we take the jet transform and then we implement. So you see that it is started with the difference equation, general difference equation, Okay, and the same difference equation for IIR system, both previous values of output and present and past values of input with different weights are considered. Then what is the system function? Hz is equal to yz by xz is equal to, if you take the z transform, okay, of individual z transform of output and input, okay, then you will get, or directly you can get the z transform of the whole series. And if you write generally in the form of summation, then you will find this expression. Okay, so you see that inputs and outputs, weights dk and ak are there, these are there. And now if you are given with such system function, first step is we have to write the ratio with considering one uh, intermediate stage, okay, or intermediate variable wz. So yz by wz into wz by xz, that is equal to yz by xz. Okay. So basically, it is a two-stage process. Two-stage process. In one stage, input is wz, the output is yz. Other stage, input is xz, output is wz. So output of the first stage is applied to the input of the second stage. Okay. So here we are writing the denominator or the reciprocal, or 1 by denominator as we are assuming that it is wz by xz. Okay. Because ak, this term, okay, 1 by 1 plus this one, summation k is equal to 1 to n akz to the power minus k. It is we assume that it is 1 by 1 plus this one is the transfer function of the first stage where input is xz. Okay. So we write wz as wz into this one, that is equal to xz. Now wz we assume xz minus, just taking all our terms right hand side, xz minus a1 z inverse plus wz a2 wz to the power minus 2, like this. Okay. This is equation 1. And the other term, okay, that is yz by wz, we take only the numerator. Okay, numerator. So in that case, yz is equal to v0 wz plus v1 z inverse wz plus up to goes up to bmz to minus 1 wz. This is 2. So first we write the difference equation as wn, in writing the inverse Z transform, wn is equal to xn minus, from this a1 wn minus 1. When we multiply z inverse with wz, it becomes wn minus 1. When we multiply z to the power minus 2 with wz, it becomes wn minus 2. Like this, it will continue up to nth term, wn minus n. This is the first. Second term, for the second equation, we take the inverse z transform. It becomes b0 wn plus b1 wn minus 1 plus b2 wn minus 2, like this. So here we see that wn is getting delayed in each equation of wn and yn in same manner. Hence, these delays can be merged. So we took the some intermediate output stage wz. Okay, wz is output to the first stage and input to the second stage, and each time this is added, this is delayed. So we can use, so comparing with direct form 1, where more number of delays were required. Okay. Here you see more number of delay element, m number of delay element, n number in input, n number of delay element in output, and here adder m number of adders, m plus 1 number of adders in the input side, and m number of n plus 1 number of adder in the output side is required. Okay, so this actually creates the complexity or processor speed, the circuit requirement. It increases the complexity of the filter structure, okay, or the processing circuitry. So in order to avoid, or speed will also be reduced. So in order to improve this speed and complexity of the circuit, this direct from 1, the direct from 2 circuit is realized by here. Although we cannot reduce the number of adders, okay, in both input and output state, but we are able to reduce the storage element or delay element, okay, by half. So only this many the delay elements, that is z inverse, okay, w goes to n minus m. Okay, that means here w goes to n minus n. Okay, and here we see that here it goes to n minus m. So this way wn is added, delayed, and first it is multiplied with coefficients a, okay, and goes each time it is multiplied with the coefficients a1 up to an, okay, in the input side, and again they are added in the output side also. The same delay is used, but it is multiplied with different coefficients b, b0, b1, b2, like that, and it goes up to bm. Now this is shown for m is equal to n, because the order of m and n, that is input orders, are same. If they different, then some delay element will not be required wherever it is lesser. Okay. So now they are added and output is obtained. So this is the way, or this is the structure for direct form 2. Now we come for one example. Okay, this is the same example we considered. Okay, implement this in direct form 2. So first we write the ratio yz by xz. Okay. Then this is the ratio we can see by just taking the z transform. We can find the ratio, and we get yz by xz is equal to yz by wz into wz by xz. So yz by wz we take as numerator 1 by denominator, numerator, so only numerator, and wz by xz as denominator. Wz by xz as denominator. So yn is equal to wn minus r cos omega 0 wn minus 1, and wn is equal to xn plus this. So this way we just take the inverse Z transform and write, you can write the expression for the intermediate function wn and the output. So this way we do it. Okay, the output is in wn. Okay, and it is delayed and weighted wn, then minus, it is multiplied with minus r cos omega 0. Okay, in the input side is wn is equal to xn. wn, this is wn is equal to xn plus what, 2r cos omega 0 wn minus 1. So 2r cos omega 0 into delayed version wn minus 1 plus minus r square wn minus 1. So r square is multiplied here, then they are added, then you finally get wn. Then this same wn is delayed, okay, delayed and multiplied with the weight. What weight? Minus r cos omega 0, and then they are added. Okay, and finally we get y. So by directly seeing the expression, okay, you can write it as this way. So the coefficients of Z inverse, okay, coefficients of Z inverse are in denominator and denominator. According to that, the coefficients are written. Okay. So this is the two structures that I wanted to discuss today, and not more than that. So have you understood this? These two structures? Direct from 1 and 2. This you will get it from book also, the pro case book. Okay. Have you understood this? Anybody please reply? Okay. No reply. Please raise your hand. Who has understood, please raise your hand. Okay. Okay. Only two. Okay. You will get. I am not uploading this file today. Okay. So tomorrow I will upload. Just go through the direct form 1 and direct form 2 realization. And now I stop my presentation. And if you have any doubt regarding the first module, if you have facing any difficulty to understand, then you ask me now.